Hey guys, Miss Davis here. You are now watching Unit 2, Skill 3A, Inverse of Functions. So take a second to pause the video, write down the essential question. How do we find the inverse of a function and how are the points related? So the first thing that we need to understand is that the inverse is a relation in which the domain and range of the original have been exchanged. So that just means the x and the y values have been switched. And then we can use the horizontal line test, which we learned about earlier in this unit. Use the horizontal line test to check to see if the inverse will be a function. Okay, so click off to the side if I have a graph and we draw a parabola of f of x, then if I do the horizontal line test and draw a line this way, it hits 2 times, so it fails the horizontal line test, which means that the inverse would not be a function. Okay? All right, so the notation that you're going to be using, if f of x represents the function, then f to the negative 1 power of x represents the inverse. Okay, so you read it as f inverse when you have the little negative 1 up top here. So we're going to take a look at the how the inverse is applied to points of the original function and the inverse, and then look at it on the graph. So the original function for example 1 is f of x equals the square root of x. So we're going to take these 4 points here and plug them into the equation for x, and we're going to evaluate them. So the first one is when x is negative 1, when you plug it in, negative 1 square rooted you can't have. It's an imaginary number, so there is no output for that value. When you plug in a 0, you just get 0. When you plug in a 1, you get 1. And when you plug in a 4, you get 2. Square root of 4 is 2. Okay, so when we do the inverse over here, f to the negative 1, f inverse, we just have to switch the x and y values. So I'm going to take all of my y values and I'm going to put them in where the x column goes, here. Okay, so I'm going to go ahead and put in nothing for x, 0, 1, 2, and then my x values I'm going to plug in for the y column over here. So those values should be negative 1, 0, 1, and 2. Okay, so the the original f of x function I'm going to graph in blue. So let's go ahead and graph this in blue. So I've got the first point, negative 1, can't graph it. 0, 0 is our first point, so right on the origin, graph that one. Next one, 1, 1, so over 1, up 1, right there. And then our third point is over 4, up 2, so 1, 2, 3, 4, up 2. Okay, so you can't go to the left any further. Your graph is just going to go like that, because to the left of that are negative x values, and you can't have a negative underneath that square root symbol. So there's just no points to the left of the y-axis. Now I'm going to graph the inverse in red. So if I graph the inverse, I'm going to can't do that point, so we start again at the origin, 0, 0, and then we're going to go 1, 1. Oh, I think I made a mistake, huh? So I'm sorry, when I switch this over here, this y value should be 4, so that's my bad. This one right here should match over there as a 4. Okay, so when I graph the points 0, 0, 1, 1, so 1 over 1 up 1, and then over 2 up 1, 2, 3, 4. Okay, so now this time my graph is going to go out that way. So that is an example of the inverse of the function. And if you can see, it's kind of like it is a mirror image over a line, and if you drew a line diagonally through them, it looks like that. So let's see if you can remember what the equation of that line would be that goes directly through the origin. It's the equation y equals just regular x, or y equals 1x. Okay, and we'll talk about that a little bit more in a second. So let's go ahead and write our domain for our original function f of x in the curly brackets as just a list of our x values from smallest to greatest. So our domain was negative 1, 0, 1, 4. So again, that was all of our x's. And our range are just 3 numbers for this one, so we're going to put them in curly brackets, 0, 1, and 2. Okay, so now when I go and look at the inverse over here, this table, the domain is the x values, right? So now in this column we got 0, 1, 2 for our x's, and our y's are negative 1, 0, 1, 4, and you should be able to see that they are just switched around. So like the domain of the original is now the range of the inverse, and the range of the original is the domain of the inverse. So they just switch around. Boop, boop. Okay. So what do you notice about the domain and range? They switch. The x and y's switch. Okay, so that's the big idea. And all inverses should be a reflection over the line y equals x. So again, that was that line y equals x that we drew up here that goes right through the origin and has a slope of 1 over 1. Okay, so up 1 over 1, up 1 over 1, starting at the origin. Okay, let's go ahead and flip over and do some algebraic problems. Okay, so when you get an equation in y equals, it'll usually be f of x equals or h of x or something of x equals, and ask you to write the inverse of that function. So if you're asked to write the inverse, then you want to follow these 4 steps over here. So step 1 is to replace the f of x with a y. So f of x is really just fancy notation for y. So I'm going to do these in steps. So step 1 is to replace that equation, or just f of x with y, and copy down the other side. So y equals 2x minus 6. Okay, then step 2 is to switch x and y. So step 2 means we're going to rewrite the equation. Wherever there's a y, you're going to put an x, and wherever there's an x, you're going to put a y. So that whole idea of switching x and y's like we did on the front page is exactly what we're doing here. It's just switching the x and y's if it's finding the inverse. Then step 3 is to solve for y. So now we're solving for, I always like to identify the variable that we're solving for, is that one right there. So we're going to go ahead and work backwards and get everything on the opposite side of the equation as y. So we're going to get y by itself. So this is actually step 3 happening here. So I'm going to write step 3 over here. We're solving for y. So add 6 to both sides. We get x plus 6 is equal to 2y. And then last step, to get y by itself, it's 2 times y, so we're going to divide everything by 2. So there's actually a couple different ways that you can write this. So I'm going to also put y on the other side here and just write it as y equals. So those 2's cancel out, and then write the left side on the right side. So one way we can write this is x plus 6 divided by 2. So that's the, just all of it over 2. Or we can write it as y equals x over 2 plus 6 over 2 and separate the numerator and the denominator as both being over a 2. Or a third way is to write it as y equals x plus 6 dividing by 2 is the same thing as multiplying by 1/2. So these are all the same, but just 3 different ways to write your function as a divided by 2 function, or a function that's been divided by 2. So we can just choose one of the 3 ways. In our step 4, we want to come back to and replace y with f to the negative 1 of x. So that's rewriting it as it's the inverse function. So let's just go with the first one. So our final answer should be f to the negative 1, or f inverse of x, is equal to x plus 6 divided by 2. Final answer. Okay? All right, the next one, let's follow those 4 steps again. So step 1, replace the h of x with a y. So step 1, we're going to write this as y equals 5 over x. Step 2 is to switch your x and y. So I'm going to put x where y was and y where x was. And then step 3, we're going to go ahead and solve for y. So when I have x equals 5 over y, the easiest way to do this one is to put x over 1 and then cross multiply. So cross multiply that way. You could have done it other ways by multiplying both sides of the equation by y and doing it that way, which is totally fine. but it's just another method. So I'm going to bring it up here, and I'm going to get x times y is equal to 5. 5 times 1 is just 5. So our goal is still to get y by itself. So my last step is to do the opposite of multiply by x and divide by x. So I get y is equal to 5 over x. Okay? And then our last step, step 4, is to rewrite it as our, in function notation, f inverse of x is equal to 5 over x. Okay? All right. Another example, we got some fractions here. So step 1, replace your, oops, I want blue there. Step 1, replace your function with y in the front. So instead of f of x, y equals 3 plus 2/3 x. Step 2, switch x and y. So x equals 3 plus 2/3 y. And then step 3, we are solving. Okay, so we're solving for y. The very first thing that I would say to get rid of is the thing that's furthest away from y. So just like a regular equation, you want to move the constant term to the other side. So you get x minus 3 is equal to 2/3 y. So now the next thing you want to do is get rid of the denominator. So if it's 2 divided by 3, how we can get rid of that 3 is multiply both sides of the equation by 3. So by multiplying over here by 3, it cancels them out because it's really like 3 over 1. And we've got 3 on the top, 3 on the bottom. They cancel out. Then we also have to multiply this whole side by 3. Not just the x, not just the 3, but we have to put parentheses around the binomial, 2 terms, and then we're going to have to distribute. So I'm going to bring this up here. So on the left side, we're going to get 3x minus 9 equals what's left over here is just 2 times y. And then our last step, if it's 2 times y, divide everything by 2. Okay, so I'm just going to copy this down with y on the left side here. So I get y equals 3x minus 9 over 2, or y is equal to 3x over 2 minus 9 over 2 if you separate the numerators with the common denominator. Or a third way would be y equals 3x minus 9 parentheses times 1/2 with the 1/2 in the front. Oops, that kind of got squished in there. But it should be 1/2 in the front with parentheses 3x minus 9. Okay, and then step 4 is to rewrite with f inverse. So f inverse x equals, just choose one of the 3 ways, 3x minus 9 over 2. Now I'm just showing you all the different ways to write them just because sometimes it's multiple choice and you have to recognize that this is the same as this is the same as that, so that you know that they're all equivalent. Okay, then the next one, we've got a square root function. So a square root function, we're going to treat exactly the same. So step 1, replace your p of x with a y. So y equals square root of x minus 4. Step 2, switch x and y. X equals square root of y minus 4. Okay, so now we're getting y by itself. So before we can add 4 to the other side, you can't add the 4 to move it because it's stuck underneath that square root. You have to get rid of the square root symbol first before you can mess with anything underneath it. So to get rid of a square root, the opposite of square rooting is to square it. So by squaring a square root, what you actually do is you cancel that out and cancels that out. So they cancel each other out because they're actually inverses of each other. So then we're also going to square the left side, because whatever you do to one side, got to do to the other. So now you're left with x squared equals, well, now you're just left with whatever was underneath the square root, y minus 4. And then our last step to get y alone is add 4 to both sides, and you are left with y equals x squared plus 4. And then our last little change here, so that was step 3 is solving, and then step 4, replacing your y with the f inverse of x equals x squared plus 4. Boom, done. Okay, so number 5 is just a multiple choice question, and it's pretty simple once you understand exactly what it's asking. So it says if the point -3, 5 lies on the graph of y equals f of x, then which of the following point must lie on its inverse? So as soon as you see inverse, just think switch x and y. So if you have the point negative 3 comma 5 to begin with, then when you switch x and y, it just becomes 3 comma negative 5, which would be number 3. Okay? All right, so down at the bottom, go ahead and answer your 2 summary reflection questions. What do we do with x and y to find inverse? And then write out some steps to kind of summarize solving.